Hello class, my name's Cole Fritzler and I'm with Group 6. We're here to talk to you about NextGen Surveillance Program, which is ADSB. So there are four main types of surveillance currently in use. We have non-cooperative surveillance, which is primary radar, cooperative surveillance, which is secondary radar, and multilateration, which is the triangulation using aircraft signals and ground stations. And then we have ADSB. And NextGen's focus is on improving and fully implementing ADSB to increase safety and efficiency in the National Airspace System. Automatic Dependent Surveillance Broadcast, or ADSB, can be defined in FAR 91-227, where it says ADSB out is a function of an aircraft's onboard avionics that periodically broadcasts the aircraft's state vector, three-dimensional position and three-dimensional velocity, and other required information as described in this section. With ADSB out, you have ADSB in, which requires additional equipment, but will display the ADSB data directly in the cockpit for the pilot to use. So ADSB uses GPS along with other navigational systems to determine the precise location and altitude of an aircraft, as well as its speed. There are two types of systems. We have the 1090 ES, which is a Mode S transponder with extended squitter, and this transmits on 1090 megahertz frequency, and the UAT, which has the capability to receive weather data, and this is transmitted on 978 megahertz. There are additional services which come with ADSB. You have the client-based service of Traffic Information Services Broadcast, which will provide the surveillance of non-ADSB equipped planes as long as they have a transponder and are in radar coverage. And then the other client-based program of Automatic Dependent Surveillance Rebroadcast, which will connect the different broadcasting frequencies of ADSB, such as 1090 megahertz and 978 megahertz. And then we have the Flight Information Services broadcast, which will provide meteorological and aeronautical information, such as PIREPs, NOTAMs, SIGMETs, AirMets, and more. And this is always broadcast on the UAT frequency. And ADSB is now the preferred method for surveillance for air traffic control.
Hi, my name is Michael Wilson. I'm an aviation student in Price. Implementation schedule. As of 2020, ADSB is required to fly in large portions of the National Airspace System. In 2024, the FAA began implementing the Surface Awareness Initiative, SIA. SIA allows air traffic controllers, ATC, to see aircraft on the ground at certain airports. There are many other developments taking place for NextGen and ADSB. See the FAA's annual report on NextGen for upcoming developments. It can be accessed through the linked page. Current status. 14 CFR section 91.225 talks about ADSB out equipment usage. ADSB out will be required in certain airspaces after January 1st, 2020. These airspaces include Class A airspace, Class B and C airspace, airspace within 30 nautical miles of an airport listed in Appendix D, up to 10,000 feet above the ceiling and within the lateral boundaries of Class B and C airspace, up to 10,000 feet, Class E airspace within the contiguous 48 states, at and above 10,000 feet, excluding the airspace at and below 2,500 feet, and in the Class E airspace at and above 3,000 feet MSL over the Gulf of Mexico from the coastline of the United States out to 12 nautical miles. See also the graphs on the right side of the slide that talk about aircraft equipment usage and installs.
Hi class, my name is TJ Denor. I'm an aviation major in Logan. Moving on to the benefits of ADSB and surveillance as a whole. ADSB, or Automatic Dependent Surveillance Broadcast, has been able to reduce separation minimums through the data that the air traffic control and pilots have access to. It allows a more accurate real-time positioning of the aircraft, And this allows ATC to work with pilots to reduce the fuel burn, noise, and emissions, along with increasing arrival throughput. Um, the systems I mentioned before include Traffic Information Services Broadcast, TIS-B, Automatic Dependent Surveillance Rebroadcast, Flight Information Services Broadcast as well. Through the use of these multiple features built into the ADS-B system on each aircraft, general safety and awareness is broadened. Information is broadcast to and between planes within a 30 nautical mile radius. Most factors that are covered within these couple of systems are available to the pilots in an easy to digest manner that allows them to adjust flight paths and any kind of adjustments that they need to make. In addition to that, specifically the system itself, ADS-B allows for smaller ground stations to link up with the satellite system to give air traffic control a more complete coverage of surveillance that we never had access to before the NextGen system, especially in places like the Gulf of America, which is one place that the FAA was specifically working on. They used some of these smaller broadcast stations actually on oil rigs in the Gulf of America. They link these up with the satellites, and it allows them to separate aircraft flying in the Gulf of America by only 5 nautical miles rather than the previous 100 miles. Things like this, it saves fuel, it saves time, it reduces delay, and it reduces aircraft emissions. Another benefit that ADS-B provides is airport surface surveillance capability. It uses that ADS-B system, the capability to broadcast between planes that have this system installed, to reroute signals and kind of subvert concrete or structures that would otherwise block radar or air traffic control signals on the tarmac at airports, and just provide better awareness. It would lead to fewer surface delays. It helps prevent runway collisions as well. All of these together is what allows ADS-B to boost the next gen system and aid in that trajectory-based operations and save time, save money, and reduce emissions, and overall provide most benefit to consumers. Some of the pros and cons, just kind of a simple breakdown of the benefits that the next-gen system provides surveillance-wise. It increases situational awareness. There's a broader surveillance range, improved accuracy and timing, reduced separation minimums, cost efficient. It improves route efficiency. It increases search and rescue efficiency. It improves overall safety. Some of the cons: the installation cost in aircraft is a concern. Privacy concerns with all of this broadcasting between airplanes and through air traffic control. And then GPS reliance. It is partly based on satellites, which the satellites are reliable, but if those satellites go down, the whole system could potentially fail.